Today we are going to discuss about imperfections in solid or crystal defects. Imperfections. Imperfections means not perfect. Clear. That is the deviations from regular ordered arrangement of particles. Deviations from the regular orderly arrangement of particles of a solid is termed as imperfection or crystal defects. That is the perfect periodic arrangement of particles in a crystalline solid exists at 0 Kelvin. When temperature increases, some deviations are present. This is called imperfection. Then imperfections are classified into two types. First one, point defect. Second one, line defect. The imperfection around a point in a crystalline solid is called point defect, and missing of entire row from the crystal lattice is called line defect. Okay, entire row point defect means missing of one constant particles from the lattice site. Then line defect means missing of entire row from the crystal lattice. Then point defects are classified into three types. First one, stoichiometric defect. Second one, non-stoichiometric defect. Third one, impurity defect. Then these non-stoichiometric defects are present in two compounds. First one, non-ionic compounds. Second one, ionic compounds. Then these non-ionic compounds show two types of defects. First one, vacancy defect. Second one, interstitial defect. Then ionic compounds show two defects. First one, Schottky defect, then Frankel defect. Then these non-stoichiometric defects are classified into two types, metal excess defect and metal deficiency defect. Then metal excess defect are of two types, due to anion vacancies and due to extra cations. Okay, then one by one. First one, which one? Stoichiometric defects. This is the classification of these imperfections. Okay, then first, stoichiometric defect. First part, stoichiometric defects. The compounds containing equal number of cations and anions are called stoichiometric compounds, and the defect that do not disturb the stoichiometry is called stoichiometric defects. Stoichiometry means equal number of cations and anions are in same pattern, same ratio. Stoichiometry. Clear? Then stoichiometric defect is present in two types of compounds. First one, non-ionic compounds. Second one, ionic compounds. Non-ionic compounds, first part, vacancy defect. Then what is vacancy defect? Simple. When some lattice sites are vacant. When some lattice sites are vacant means, this is, here we represent a sphere that is marked in rose color. This is completely occupied sphere. This is one completely occupied. But here, this sphere is vacant. Okay, this particle is vacant. So, the particles are arranged in lattice site. Then this is the vacant space or interstitial site. Clear? So, some some lattice sites are vacant. Then here this one and this one. So lattice sites are vacant. So density of the crystal decreases. In vacancy defect means, in vacancy defect, when some of the lattice sites are vacant, this is called vacancy defect. Then second one, interstitial defect. When some constituent particles occupies the interstitial site. When some constituent particles occupies the interstitial site. This is interstitial site or vacant space. Okay. But some particles occupies the interstitial site. So density of the crystal increases. That means particles occupies the interstitial site means some of the particles occupy the interstitial site, hence the mass increases, so density also increases. So non-ionic compounds, stoichiometric defect is present in non-ionic compounds, are classified into two types. First one, vacancy defect. Second one, interstitial defect. Vacancy defect means the defect arises due to the vacancy of some of the lattice sites. Then here, interstitial defect means the defect arises due to some of the constant particles occupies the interstitial site. Then second one, ionic compounds. This is very, very important for examination. First one, Schottky defect. Schottky defect means here this stoichiometric compound containing, these compounds containing or ionic compounds containing A plus B minus, A plus B minus. A plus means A plus positively charged ion. This is cation. B minus anion. So Schottky defect arises due to missing of equal number of cations and anions from the latticite. Missing of equal number of cations and anions from the latticite. That is here we are missing one cation, shaded like this. That is A plus is missing from the latticite. Then B minus is also missing from the latticite. Clear? This A plus or B minus, A plus or B minus, anyone, A plus and B minus, but equal number of cations and anions are missing from the latticite. Clear? Okay, here A plus, then B minus. This is called Schottky defect. Okay, so what is Schottky defect? The defect arises due to missing of equal number of cations and anions from the latticite. Here, size of cations and anions are almost equal. Then, cations and anions are missing from the latticite, so mass of the crystal decreases, hence density also decreases. Then, here Schottky defect is present in a compounds containing high coordination number. Coordination number means, what is coordination number? Coordination number means the number of touching particles around the considered particle. Then Schottky defect is present in a compounds containing high coordination number. Example, sodium chloride, cesium chloride, silver bromide, etc. Then second one, fungal defect. The defect arises due to missing of cation from the latticite. That is, here A plus is missing from the latticite, and it occupies the interstitial site. Missing of cation from the lattice site, and it occupies the interstitial site. Here, that is, here A plus is missing from the lattice site and it occupies the interstitial site. Clear? Then the properties. First one, size of cation is less than that of the anion. Density constant. That means here there is no ion is missing from the latticite. Okay, density constant. Then it shows a compounds containing low coordination number. Low coordination number. Example, ZNS, AgCl, AgBr. Here we notice that in Schottky defect and fungal defect, one example is there, that is AgBr. AgBr. So silver bromide shows, AgBr shows both Schottky defect and fungal defect. Okay. Schottky defect means missing of equal number of cations and anions from the latticite. Fungal defect means missing of cation from the latticite and it occupies interstitial site. In Schottky defect, density decreases, but in fungal defect, density constant. Schottky defect is shown by a compounds containing high coordination number. Fungal defect is shown by a compounds containing low coordination number. Clear? Example. Then Schottky defect and fungal defect, both the defects are shown by which one? Which compound? Silver bromide. Next, non-stoichiometric defects. Non-stoichiometric defect means the defect present in a non-stoichiometric compound is called non-stoichiometric defect. The defect present in a non-stoichiometric compound is called non-stoichiometric defect. Okay, first one, metal excess defect. Metal excess defect. The metal excess defect, first one, A part, due to anion vacancies. Clear? Clear? Due to anion vacancies. That is, in metal excess defect due to anion vacancies. This anion vacancy, anion means negatively charged ion. Anion vacancy create a hole. Anion vacancy create a hole. Okay. Anion vacancy create a hole. Here hole is there. Anion vacancy create a hole. Then, in order to get the electrical balance, here B minus is missing from the latticite. Then electrical balance means containing equal number of positive and negatively charged ion. So one anion is missing from the latticite. Positive charge is greater than that of the negative charge. Then in order to get the electrical balance, electrons are trapped at the vacancy of this anion. here electron is trapped. Electrons are trapped at the vacancy of this anion. Clear? This is called F center. F center. F center means Farben center or colored center. Okay, Farben center or colored center. Farben center or colored center. Okay, F center. Then this F center imparts a particular color to the crystal. F center imparts a particular color to the crystal. Once more. In metal excess defect due to anion vacancy create a hole. Clear? Then in order to get electrical balance, electrons are trapped at the vacancy of this anion, that is hole. The center is called F center. It imparts a particular color to the crystal. For example, lithium chloride crystal is heated in presence of an atmosphere of lithium vapor. It imparts pink color. Sodium chloride crystal is heated in presence of sodium vapor. It imparts yellow color. Potassium chloride crystal is heated in presence of potassium vapor. It imparts violet color. This is due to F center. F center. In general, these lithium chlorides are alkali metal halides, are heated in presence of alkali metal vapor. It imparts a color because of F center. Okay, what is F center? In metal excess defect due to anion vacancies, anion vacancy create a hole. Then in order to get electrical balance, electrons are trapped at the vacancy of this anion. This is called F center. It imparts a particular color to the crystal. Okay. Then second one, due to extra cations. Due to extra cations. Here, some cations occupies the interstitial site. Some cations occupies the interstitial site. Some cations occupies the interstitial site. Interstitial site means vacant space, vacant site, interstitial site. Okay. Some cations occupies the interstitial site. This is interstitial site, interstitial site. This is interstitial site. Okay, vacant space. Okay. Some cations occupies the interstitial site. Then in order to get electrical neutrality, some electrons occupies the neighboring interstitial site. For example, when zinc oxide is heated, the white colored crystal become yellow. On heating, it loses oxygen. That is, zinc oxide Zn gives Zn2 plus 2 electron plus half O2. Here Zn2 plus occupies the interstitial site. Okay. Then in order to get electrical balance, these 2 electrons also occupies the neighboring interstitial site. This is due to extra cations. The metal excess defect due to extra cations. Okay, clear? In metal excess defect due to extra cations, some cations occupies the interstitial site. Then in order to maintain electrical neutrality, some electrons also occupies the interstitial site. Okay, so electrical neutrality is maintained. Okay, this is metal excess defect. First one due to anion vacancy, second one due to extra cations. Okay, clear? Then second one, non-stoichiometric defects are classified into 2 types. First one, metal excess defect. Then second one, metal deficiency defect. Symbol. This metal deficiency defect arises due to symbol. Metal deficiency defect arises due to missing of metal deficiency symbol. Metal deficiency defect arises due to the missing of cation from the lattice site. Cation from the lattice site. Then this defect is commonly present in transition compounds. Transition element compounds means D block element. Okay, example FeO like that. Okay, the metal deficiency defect arises due to the missing of cation from the lattice site. Missing of cation from the lattice site. Okay, missing of cation from the lattice site. Symbol. Okay, here in rose color marked represents, rose colored sphere represents missing of cation, that is A plus is missing from the lattice site. Okay, clear. Okay, this is non-stoichiometric defect. And third one, impurity defect. Impurity defect means this defect arises due to the presence of foreign particles present in a crystal. Impurity defect arises due to the presence of foreign particles present in a crystal. Foreign particles present in a crystal. Foreign particles present in a crystal. Okay. For example, sodium chloride containing some amount of strontium chloride. Impurity is a strontium chloride. Sodium chloride or sodium chloride containing little amount of strontium chloride is crystallized. Strontium chloride, SrCl2. Okay. Then some of the sites of Na plus ion occupies by this Sr2 plus ion. That means strontium chloride SrCl2 decomposed to get Sr2 plus and 2Cl minus. Here some of the sites of the Na plus ion occupies by Sr2 plus ion. Sr2 plus ion. So here Na plus is replaced. Okay. Then instead of Na plus, here Sr2 plus ion is occupies. Okay. But here each Sr2 plus replace 2 Na plus ion. Each Sr2 plus replace 2 Na plus ion. So this Sr2 plus, each Sr2 plus and strontium ion replace 2 Na plus ion. So one Sr2 plus ion occupies the place of this Na plus ion. Then here this Na plus ion is missing. Okay. Missing. Clear? Na plus ion is missing. Na plus ion is replaced. This Na plus ion is missing. Okay, but here Na plus is missing from the lattice site, but here Sr2 plus ion is occupies the position of this Na plus ion. Okay, because charge of Sr2 plus how much? 2 plus. So 2 plus 2 positive charge replace 2 Na plus ion. Net charge neutral. Clear? Then that is each strontium Sr2 plus ion replace Na plus ion. It occupies the sites of one ion and the other sites remaining vacant. The cation vacancy produces equal number of Sr2 plus ion. Okay, that is the impurity defect arises due to the presence of foreign particles present in a crystal. For example, strontium chloride containing some amount of foreign particles, that is strontium chloride. Sodium chloride containing some amount of foreign particles, that is little amount of strontium chloride as a foreign particle. Here some of the sites of Na plus ion occupies the Sr2 plus ion. Each Sr2 plus replace how many number of Na plus ion? Each Sr2 plus ion replace how many number of Na plus ion? 2. Replace 2 Na plus ion. Okay. It occupies the, that is Sr2 plus occupies the site of one ion. Here, that is Sr2 plus occupies the site of one ion, and other site or other site remaining vacant. This one vacant. Okay. Clear? This defect is called impurity defect. That is later we can draw the picture like this. Draw the crystal structure like this. That is here vacant. Here this one vacant. Then Cl minus. Then structure is like this. Here, this is the crystal structure of NaCl. NaCl. Crystal structure of NaCl. Okay, it's NaCl. NaCl. Then Sr2 plus. Here Sr2 plus. Okay, and Cl minus, then here Cl minus, here Cl minus, Na plus, Cl minus, Na plus, Na plus, Cl minus, Na plus, Cl minus, Cl minus, Na plus, Cl minus, Na plus. That is, this space is vacant. Okay, then here it occupies Sr2 plus ion. Clear? This is the impurity defect. Okay, that is, imperfections are classified into, later, that is, we concluded that imperfections are classified into two types: point defect and line defect. Then these point defects are classified into two types, three types: stoichiometry defect, non-stoichiometry defect, and impurity defect. Non-stoichiometry defect are of two types of compound shows, that is, non-ionic compounds and ionic compounds. The non-ionic compounds shows two types of defect, that is, vacancy defect and interstitial defect. Okay, this is the imperfections, classification of imperfections. Okay, thank you.